Hi, I'm Tom Kruplinski.
And I'm Eli Beard.
Welcome to Brand Central's Introduction to Personal Computers. In the next 30 minutes, we're going to demystify these devices which seem to have become a greater and greater part of our everyday lives. We'll discuss the language of computers and define those funny terms like bit and byte, and we'll even discuss the various components that make up a computer. But first of all, what exactly is a personal computer? What's it good for? Why would anybody want one? You know, that's a good place for us to begin. A computer is a tool. Its purpose is to manipulate and store information. It can perform simple arithmetic operations such as addition, subtraction, multiplication, and division. It can perform text manipulation or even simple logic operations like comparing the value of two numbers or comparing two words to see if they have the same letter. Everything that a computer does is based on simple operations. By combining these operations, we can use a computer in any number of ways. These operations make up the software which controls and manipulates the computer's hardware.
Software, hardware. Let's slow down a minute. Let's start by defining those terms. You know, a computer system can be loosely compared to a stereo system. First of all, the hardware is the physical equipment. You know, the stuff you can drop and break. The software is a set of instructions that directs the hardware to do what we want it to do. In the case of the stereo system, the software is kind of like this CD. Actually, the computer's hardware can be broken down into three basic components: the system unit, the keyboard, and the monitor. The system unit is the heart and soul of a personal computer. It houses the microprocessor, which is really the brain of a computer.
I just happen to have a microprocessor here so you can see it. It may look pretty simple, but this is the part that actually performs the processing of information. Whether you're adding 1 plus 1 or calculating the distance to the moon, this is the part that actually does the work. We'll be talking about these in more detail a little later on.
Thanks a lot, Tom. I'm looking forward to it. The next device we're going to talk about is the keyboard. The keyboard is a device that allows the user to input data to the system. It's really one of the main ways of telling the computer what we'd like it to do. And it's known as an input device. And finally, we have the monitor, which allows us to see what's going on and is called an output device. So to return to the stereo analogy, the system unit is like the stereo amplifier. The keyboard would be like a CD player, and the monitor would be like your speakers.
Okay, so we've covered computer hardware, but what about software?
Well, like we said earlier, software is the set of instructions that tells the hardware what we'd like it to do. There's two major categories: application and operating.
I've got some different software titles here. I've got some word processing software for word processing, got some accounting software for accounting, and, oh, my favorite, game software. The more software titles you have, the more things your computer can do. We call this software application software. In simple terms, operating software gives your computer a way of understanding the data the user inputs. You see, when you type in A, B, C, or D, the computer really has no idea what you mean. So the operating software gives your computer a means of translating what you type on the keyboard into a language that the computer can understand. Computers register data in one of two ways, either by the presence or absence of electricity. If electricity is present, it's registered as a 1. If electricity is absent, it's registered as a 0. This is the smallest unit of computer information, and we call that unit a bit. When bits are grouped together in patterns of 8, they form another unit called a byte. A byte is equal to a single character, such as a letter of the alphabet.
Here's a listing of the letters of the alphabet and a comparison of how your computer would see them. As you can see, it's kind of like assigning Morse code to each letter.
Now, as you can see, a byte is still a pretty small unit of information, kind of like a single letter from the novel War and Peace. It's convenient for us to have some larger units of information to work with. Now, a kilobyte is equal to 1,024 bytes. To put that in perspective, say a half page of text. But there are even larger units of information. A megabyte is equal to 1,024 kilobytes, say 500 pages of text or a good-sized book. The next unit of information, called a gigabyte, is equal to the amount of information we would find in a large encyclopedia. And our final unit, the terabyte, well, let's just say we're dealing with the amount of information in your average public library.
Well, enough terminology. Let's take a look inside of the computer, at its parts and what they do. You know, a computer's components roughly duplicate an office and its fixtures. A desk, a typewriter, a file cabinet, and even the office worker themselves. As long as we can relate the function of a component to the fixture within the office, understanding the inner workings of a computer should be pretty simple.
Well, here's the primary component of our personal computer. It's called the system board or motherboard, and it holds many of the important components of a personal computer, kind of like the four walls of our office hold our office worker and office fixtures. Now, like most modern circuit boards, it's made of fiberglass and it has a good many components attached to it. These include the microprocessor, the RAM, the ROM, the expansion slots, the system clock, the video system, and the data bus.
The microprocessor is the brain of the computer. It controls all of the other components in a computer, just as the office worker controls all the components of an office.
Another important component of the system board is the random access memory, or RAM. Like a desktop, this is where the computer stores the information that it's currently working on. The more RAM we have, the larger our desktop and the more things we can do at one time. And like our desktop, when the information is no longer needed, it's filed away and replaced with new information.
By the way, don't forget, RAM requires a constant electric current. Turn the power off, and the contents of RAM are lost. RAM is measured in megabytes, and all computers today come with a certain amount already installed. As your needs change or increase, you can add even more. Here on our motherboard, you can see the sockets where additional RAM can be installed. The next component on the system board we should talk about is the ROM. ROM is another three-letter acronym that stands for read-only memory. We can find it on our motherboard here. Unlike RAM, which loses its contents when the power is shut off, ROM retains its information indefinitely, even without electric current. Now, the purpose of the ROM in a computer is to hold very special software that tells the microprocessor how to communicate with the other components that are connected to it. The computer is designed so that every time it's turned on, the microprocessor will read the contents of the ROM before it does anything else. This way, we know that the microprocessor will always be able to communicate with its memory and any other components that come with the computer.
I'm going to turn on this computer over here, and if you watch carefully, you'll see the information in ROM called the BIOS. That stands for Basic Input-Output System, and what it is a fancy term for software that tells the computer what it's got and how to use it. The next important component that we need to talk about is the system clock. The system clock regulates the speed of all the other components on the system board. The faster the clock speed, the faster the data is processed. Of course, the clock speed of a computer is much faster than any ordinary watch. Clock speeds are measured in megahertz. 1 megahertz equals 1 million cycles per second. Some of today's faster computers operate at 66 megahertz, with even faster models on the way.
Another important component of the motherboard is the video system. You may have noticed that a computer monitor looks a lot like a television set, and it's similar in a lot of ways. For instance, right now, this television and this computer monitor are displaying nothing at all. In the case of the television, it's a broadcast signal that's missing. In the case of the monitor, the video system isn't transmitting. You see, a computer's video system is like a TV station in miniature. It takes information from the CPU and converts it to a signal which can be fed along a cable to the monitor.
We've discussed all of the major components of the motherboard except one. All of these components are tied together by electrical wiring over which the data is transmitted. We call this wiring the data bus. Now you can think of the data bus as an information highway, and think of the bits of data as the individual cars. Like a highway, a data bus is rated according to how many lanes of traffic it can support. In all cases, the wider the data bus, the more effectively data will be transferred from one component to another.
You know, a computer wouldn't be very useful if every time we turned the power off, we lost all the information inside. Yet we know that's exactly what happens to the system's RAM every time we turn the switch to off. Fortunately, there are other safe ways of storing data without a constant flow of electricity. For instance, the music on this cassette is stored magnetically on the tape inside. Even if I turn the tape deck off, the music is safe inside on the tape. Data can be stored much in the same way. In fact, some early PCs even used tape for storage. But unfortunately, tape does have some real disadvantages. For example, if I wanted to listen to track number 3 of this tape, I'd have to fast forward and rewind many different times in order to get to the beginning of that song. And that could be a real hassle.
Yeah, that's why I still love vinyl LPs. Just drop the old tone arm onto track number 3 and you're right into your song. And that's why computers move pretty quickly from tape to discs. Like a record album, a disc can be randomly accessed simply by moving a read-write head across the surface. This allows you to find what you're looking for very quickly.
I've got one of each kind here taken apart. Don't try this with the disc that you plan on using. Inside, you've got a plastic disc which is coated with magnetic particles. These discs come in double density or high density formats. You see, by packing the tracks of data closer together, it was discovered that storage capacity could be greatly increased. From 360 kilobytes to 1.2 megabytes in the 5 1/4 inch size, and from 720 kilobytes to 1.4 megabytes in the 3.5. Most of the disks in use today are of the 3.5 inch format. How do you tell the difference between the two kinds? On a 3.5 inch disk, it's easy. Just look for the HD symbol, which stands for high density.
Of course, floppy disks are fine for transferring small amounts of information from one computer to another, but to run programs on a day-to-day basis using floppy diskettes, well, can get a little cumbersome. Now, fortunately, there is an alternative to all of this, and it's called a hard drive. A hard drive functions on the same principles as a floppy disk, but instead of using these plastic disks, it uses disks made of metal or glass that are mounted inside a case and located permanently inside your computer. Now, because the disks are rigid, they can store much more information which can be retrieved very quickly. Now, I've got one taken apart here so that you can see how it works. Notice that the disks themselves are very highly polished. The read-write head must never come in contact with the actual disks. You see, once the disk starts spinning, a cushion of air lifts the read-write head off the surface so that it literally flies above the surface of the disk. If the read-write head ever should actually come in contact with the surface of the disk itself will be ruined, and worse yet, the data that was on it may not be able to be recovered.
Because a hard drive stores so much information, it's like the file cabinet in the office analogy. It holds lots of information for easy retrieval. You know, it's very important to have a good working knowledge of the different ports and connections on the back of a personal computer. This is where the different components like a keyboard or monitor are going to plug in. You're going to notice that a lot of the ports look very similar. If the wrong connector is used to attach a new device, the computer may fail or worse yet suffer permanent damage.
Okay, well, why don't we turn this baby around and give him a better look? Now here's a quick rundown of your most important ports. Right here is your parallel port. Now, this is normally where you would connect a printer. Over here is your keyboard port for connecting your keyboard. Right next to it is the mouse port for connecting a mouse. And you notice how similar these two are? By the way, a lot of people make this mistake. They plug the mouse in the keyboard port. They plug the keyboard in the mouse port, and you notice they both fit. Then, realizing that neither one works, they'll try and switch them back again while the computer is still on. This can cause permanent damage to your mouse port. Now, right over here, this is your video port. And this is normally where you would be connecting your monitor. And way down here is your serial port. There are a variety of devices that can be connected to this, and we'll be talking more about them in future programs.
Personal computers are designed in many different sizes and shapes, each one with a particular user's needs in mind. As an example, this notebook computer is designed for mobility, or perhaps for someone who just has limited space. The desktop computer, on the other hand, is designed for maximum expandability. We're going to open this one up so that we can see the expansion slots inside.
Well, Eli, looks like we've got 4 open slots in there.
Yeah, Tom, these sockets allow me to add additional circuit cards that add new capabilities to my PC.
Like the sound card here?
You bet, Tom. After all, your personal computer only comes with a little speaker that's meant just to beep if you do something wrong. By adding this sound card, you can actually get stereo sound from the software that'll support it.
Well, let's pop it in.
Now you can see here that this sound card has a port on it for some speakers. Now I just connect up my stereo speakers and
You know, that looked pretty easy.
well, Tom, sometimes it is easy, but often you'll have to make adjustments to the card in case it conflicts with something else in the computer. That's why really only a trained technician should make this type of an upgrade. Otherwise, you spend hours and hours of time trying to make it work, and really sometimes that's more frustrating than it's worth.
Of all the parts of a computer, no other is as impressive as the microprocessor. Modern technology has made it possible for us to miniaturize electrical components that would have filled a room 20 years ago into something that's small and relatively inexpensive to manufacture. They're made by companies like Intel, and they have names like 486SX and 486DX.
You know, Tom, a lot of people get really confused with the different names. 46SX and 46DX.
You're right, Eli. And with all the different models that are out there and all the confusing numbering systems, it's getting tougher and tougher to tell what's what. I mean, take a look at this listing. And this is only a partial recent list. There are many more types, and they're changing all the time. So let's just concentrate on the main differentiating features. The main differentiators are the amount of information that a microprocessor can deal with at one time, the size of the data bus that delivers the information to the microprocessor, whether or not an integrated cache is present, and whether or not an integrated math coprocessor is present. Let's talk for a moment about each feature. The amount of data that a microprocessor can deal with at one time is measured in bits. Remember that a bit is equal to a 1 or a 0. A 16-bit microprocessor processes 16 bits of information at one time. A 32-bit microprocessor processes 32 bits of information at a time. Most microprocessors today are the 32-bit types, but there are 64-bit microprocessors, and who knows how far they'll go. The data bus is simply the wiring connected to the microprocessor. The wider the bus, the more quickly data can be sent to and from the microprocessor. However, a wider data bus means that more circuitry is involved, and that adds to system cost. To solve this problem, some microprocessors are 32-bit types that are mounted in a 16-bit data bus. Now, although this reduces efficiency, it does allow you to gain some of the benefits of the more advanced 32-bit microprocessors.
You know, Tom, it sounds like you're talking about a 386SX.
You're right, Eli. The 386SX microprocessor was a 32-bit chip mounted in a 16-bit data bus.
Okay, well, you know, you mentioned another feature earlier, which was cache. And I'll bet you there's a lot of people out there thinking this is what you're talking about.
No, Eli. I'm talking about cache spelled C-A-C-H-E, and it's a bit of a different concept. Remember, we said that a microprocessor keeps the data that it's currently working on in RAM. Well, that information has to travel along the data bus to get to the microprocessor. With the newer, faster microprocessors, that can actually mean that they're spending a lot of time waiting for the data to travel along the data bus. And while they're waiting, no work is getting done. To solve this problem, starting with the 486 model, the CPU was designed with a small amount of its own RAM. This RAM could then hold the data that was being used repeatedly without the microprocessor having to wait for it to be sent along the data bus from system RAM. This on-chip memory is called integrated cache. So instead of checking the main RAM each time, it checks the cache first. And since the microprocessor is often using the same data over and over again, it's probably going to find what it needs much of the time in the cache. That should make the computer run a lot faster. Cache is one of the most effective ways of speeding up a computer. And the bigger the cache, the faster the computer will run. Today, integrated cache memory can be anywhere from 1 to 16 kilobytes. And you can be sure that future generations of microprocessors will have even larger caches.
You know, Tom, that leaves just math coprocessors to talk about.
Hey Eli, can you work out this math problem for me?
Come on, Tom, you know I have trouble with math. That'd take me all day to figure out.
Would it be easier if I gave you a calculator?
You bet. I could figure out nothing flat then.
Of course you could. And that's exactly what happens when you add a math coprocessor to a microprocessor. It gives it a big boost in its math solving capabilities.
So if the microprocessor is solving a difficult problem, it should run a lot faster if it has a math coprocessor.
That's right, Eli. Although much of the time the microprocessor is not working with this kind of really complex math, when it is, a math coprocessor can give a big boost to efficiency.
Say, Tom, isn't a math coprocessor the difference between a 486SX and a 486DX?
That's right, Eli. The 486SX did not have an integrated math coprocessor, but the 486DX does. So if somebody's going to be doing a lot of math-intensive computing, such as CAD or computer-aided design, they'd definitely benefit from having the 486DX. So to recap, the important differentiating features between microprocessors are the internal processing capability, the width of the data bus, whether or not an internal cache is present, and the presence or absence of a math coprocessor. And that's all we have time for today.
You know, Tom, in our next program, we're going to talk about some of the devices that can be connected to a personal computer.
See you then.
Bye-bye.